Hey, Marius.
Hello.
So today we're going to do some pair programming, and you are going to show me how to make some 3D generative art.
Sounds fun.
And we are shooting in the Prismic studio. I'm Sam at Prismic, and Marius is a pretty incredible creative developer. So Marius, just to get started, can you tell me what is generative art?
So for me, generative art is something that you create that doesn't involve really any decisions per se. For me, it involves a lot of code, but it can be with robotics even and stuff like that. So for me, it's just a code that you created that then draws something on the screen, and that is generative, so involving a bit of random stuff in the equation.
And for you personally, what do you like about generative art?
It feels like you can never run out of ideas, first of all. And also, when you create the thing, I love the fact that the thing that you create will never be twice the same. And I really like this idea of anything that you create that you see on your screen. If you close the window, let's say, for example, on the processing, you will never re-see that thing. And that's what I like about it, the uniqueness of it. We can do the parallel with NFTs, for example. For me, it's a bit the same. It's your own thing that you saw one time, and now it's gone.
That's pretty cool.
I like it. I like it like that. Yeah.
So we're going to do some pair programming. Marius can see my screen, but he can't do anything. Personally, I have a little bit of experience with JavaScript and CSS, but I'm by no means an expert, and I have no experience with generative art or 3D. So Marius is going to look at my screen and tell me what to do and walk me through the process of making something.
Yeah.
Something cool, I imagine. So Marius, I'm on GitHub, and you're going to set me up with a starter that you created?
Yeah, exactly. So I'm a big Vue guy. I like to use Vue.js because it has already a lot of tool sets that are pretty nice to have. You don't have to build almost anything. So if you go on my GitHub page, if you can find it.
Yes,
Marius Ballot,
you are the one, Marius Ballot. Okay, here we go. I'm on your profile.
Perfect. And I think it's pinned. Yeah, it's the one on the bottom right. 0421. Yeah, Vue 3 starter.
Okay, so we've installed our dependencies. What do I do?
So now, I think you are a bit of a Vue guy, right?
I have some experience with Vue, yeah.
Okay, so now we can start the server. I actually added a script, so you can do simply npm start.
In French, we say tac, tac, tac.
Tac, tac, tac.
Tac, tac, tac.
And there we go. Nice. And if you use your mouse to move around.
Whoa.
There we go. We have a cube. So that's it.
Okay.
We are finished.
That was really great. Nice doing this with you.
So
I now know 3D.
So yeah, this is the starter. I just placed a cube there just to see that it's working, because before I had just a black screen and I wasn't sure that it was working. But now we can see it does. So now on the screen we have a cube with a custom GLSL shader, and we are not going to use that today because GLSL is a bit of a rabbit hole. But we will have some fun with that. So what are we going to try to do? So I wasn't prepared to do this thing, but an idea that comes to the top of my head, which is I think would be pretty easy to do and will still be kind of funny to see on the screen. We'll create a kind of ball with different strands. Strand. Yeah, this is the word. Strands.
Yeah.
There we go. And made out of cubes, bits of elongated cubes along the y-axis. Place them with a rotation, with a random rotation, to create a sort of a ball. And so this will be our generative part. And maybe make them move. And yeah, let's just see what happens. So if you go back to VS Code, and so here is the architecture of my project. If you open SRC for the sources, so you have your typical Vue stuff, the app view.
So we have our typical Vue stuff here?
Yeah, so we have our typical Vue stuff with the app.vue. And if you go into the components folder, yeah, this one, you can see the 3scene.vue. So this is my Vue component that is taking my 3scene. And as you can see in there, we have the main 3scene script that you can see right now that is initted and then placed to this particular div tag. And so where is the script? It's in classes, the folder classes that is in SRC.
Okay.
Yeah, and there we go. We have the main 3scene.
Okay.
Yeah, we also have an example class.js because since I am a bit lazy, I've created this class so that I can Command C, Command V when I created a new class.
Okay.
So yeah, so we will mostly work in there.
In this main
Yeah,
3scene.js.
yeah.
Okay.
I don't think we'll need anything else actually. So if you go
So
down,
we're going to write this entire program in JavaScript. So like we're not actually going to be writing in the view component. So just to understand a little bit better what's happening here. So app.view kind of renders our entire app. So obviously nothing happens there, but you are importing the view component 3scene to the app and then placing it in the app. So in 3scene.view, you have this container, and this is like the container for the animation.
It's the container for the canvas that is having the WebGL context.
Okay, and then in view syntax, we're saying when this mounts, so like when the app is fully loaded in the browser, we're taking this script that we're working on and knitting it with the container. Yeah,
so we pass in the container so that Three.js knows where to render this 3D scene. So we have a lot of imports right here if we go from the top to the bottom. So Three.js, obviously. Object controls, it's just to control the camera with your mouse. It's something already integrated in the Three package. RAF, it's my own request animation frame controller. It's just to have one single. So you know what request animation frames are in JavaScript? Okay. So do you know a bit of Unity, maybe?
No.
Okay. In video games.
Okay.
You have something that is drawn on your screen X times per second, usually 60 times per second. In JavaScript, there is this pretty nice thing, the request animation frame that will simply recompute a function a number of times per second, usually 60 times per second. So this is a request animation frame. So the idea of this RAF thing is to have one single function that will handle every single thing that I need to redraw on the screen every time.
And it's doing it at a standard rate as opposed to using something like set interval, which is very unreliable.
Exactly. This was the old way of doing that, actually. And I wouldn't say it is a young or brand new feature, but it was invented for that. That particular thing.
Okay.
And then a bit below, we will not go into details into that, but those are my two custom shaders.
Okay.
So you've heard of shaders before? Maybe?
This is like, we've got blue here, kind of like this like lavender color here, purple here, and as we rotate, the colors change. Is that because of the shader?
Yeah. So in computer graphics, so from what I know of it, again, a shader is basically the color given to a particular object. And you do that with code that is directly understood by your graphics card called GLSL. And this is a bit similar to C. It is not really nice to learn. It's as I said, it's quite the rabbit hole when you go down this route. But I created a simple shader so that I just have something ready if I need to do a custom shader.
Mm-hmm.
Yeah.
Okay, cool. But we're not going to touch that too much today.
No, we are not going to touch that. Actually, we are going to get rid of this in a moment. But yeah.
Okay.
And so from down there, we're not going into too much details. But as I said, this is just the setup to have something that works. So this is a simple JavaScript class. This is the thing we have to understand. That is pretty basic, actually. In Three.js, to make something appear on your screen, you need multiple things. You need the container that will be drawn to the renderer. So this is our scene. And to this scene, you're going to add objects. How does those objects work in Three.js? It is pretty simple. Those are called mesh. And a mesh is composed of two things. The geometry. So this is, if you would like, the skeleton of the object. So for example, here the geometry is a cube.
Okay.
And a material. And so the material, as you might understand, is just the color of this object that it is going to be drawn to the screen. So here, the current material is my custom shader. So this line I have instanced a material, called the shader material. Next, you can see the cube which is another constant.
So this is the shader that you showed us earlier.
Yeah, and
the simple frag.
Yeah, a shader is composed also of two things: a vertex shader and a fragment shader.
Okay.
Yeah, so pretty.
So there's a lot going on here, but we have a shader.
There is. Yeah, we do have a shader.
Shader material.
Below that, we have our mesh that is composed of, as I said, you can see in those parentheses, two things: the geometry on the left, the box geometry, and on the right, our material. So our shader material.
So this is, no pun intended, basically just Three.js out of the box. This is just a standard.
Yeah.
It really was not meant to be a fairly bad joke, but there it is.
Actually, I think every tutorial ever will show you how to draw a box on a screen, just to start.
But there's nothing to it. You just say box.
Yeah, it's pretty simple. And in this particular box, you can pass in arguments. Like, for example, the first three are the X, Y, and Z size of the box. So, for example, if you say 1, 10, and 1, so what will you have, actually? What do you think you will have?
I think I'm going to have like a big flat, like a box that a necklace would come in.
Yeah, and since it is X, Y, and Z, so we'll have something like this normally.
Whoa.
Yeah, I think I know my thing. Oh, and you can scroll to, zoom out.
So it's like a chocolate bar or something.
Yeah, a pretty neon chocolate bar that I wouldn't trust, but a chocolate bar.
I'll eat that in a second. So can I change this to like circle geometry?
Sphere geometry?
Sphere?
Yeah.
Apparently I'm not very good at geometry. Is that going to work?
Maybe not with the arguments. Yeah, so it works, but with the arguments you passed, this is something
different is happening.
If you pass in maybe 10 and 10, this will be the number of edges you have on the X and Y axis of the sphere.
And we can see here in the hints, we've got radius,
there we go.
number.
Oh, radius. So yeah, the first one is the radius.
Height segments number.
Yeah, you should put 1 instead of 10 as the radius because we'll be inside the sphere if we do that, I think.
Okay.
Okay. And if you put another 10 next to the one you've put, you will have a pretty smooth sphere.
Nice. Okay.
As you can see, it's not rocket science at all. This is the thing with Three.js. It is pretty nice.
But they are using Vue.js in rocket science at this point.
Oh yeah. Yeah, actually they did in SpaceX, right?
Yeah.
Yeah. That's pretty nice. That's pretty cool.
So it kind of is.
Yeah, it kind of is.
So then we create this cube.
So yeah, you create this cube and then you need to add it to the scene.
Mm-hmm.
And that's just it to put something on your screen.
Cool.
Yeah. And so from there, as you can see, we have an event listener resize that just is to have something responsive. I'm not going too much detail into that.
Okay.
And then, this is my ref. So I subscribe a function to this request animation frame. So this is the update function that is a bit below, as you can see, line 61. And this is just redrawn every single frame.
So this is it's just taking the standard animation frame rate from the browser and just saying every frame update this.
Exactly. If you would like to put a console log in the updates and open your console, you will see that it's just rolling and rolling.
Whoa.
Yeah.
Okay. Does make me anxious. So I'm going to get rid of that console. Okay.
So this was a nice tour.
Yeah.
Maybe now we can start. What do you think?
Let's get into it. I mean, I'm already in over my head, so I feel started.
So let's get rid of this cube and shaders, actually.
We're going to get rid of, so you want me to delete all of this?
Yeah, all the dummy cube and even, this,
Okay.
Perfect. You got it. So we need a bit of a plan, actually. So as I said, we're going to need to create a sphere made out of strands. So for that, we will need something to contain each and every one of those strands to then draw them to the screen. So for that, let's say, we need a kind of group of strands. So we'll need to create a 3 group. So for that, fairly easy. If you go here and let's say we're going to need to create a variable that is going to be accessible to the entire class. So not a const, so a this, and let's call it strand group, let's say. Yeah, and this is equals to a new 3.group. So with the, yeah, perfect. So what is that essentially? It is just a placeholder in which you can place objects, exactly like the scene.
Okay.
As you remember, right before we did scene.add the cube to add the cube to the scene, but now we can do this.strandGroup.add the cube that we did before. But it will not be drawn to the scene. So after that, we will only need to do this scene.add this strand group.
Okay.
And that's it. And that is pretty interesting to move around everything at once and just have a place to have everything and just access them.
Okay, so this is because we're going to be working with multiple objects.
Exactly.
This makes it easier.
Yeah.
Okay.
So now that we have that, we need to put something in it. So let's say we'd have a certain number of strands, so we will do a loop. So a for loop, let's say. With how many strands would you like to be in it?
20.
20. Let's do a for loop of 20, actually. So,
how do I write a for loop?
So you need to create a variable that is going to change over time. So let's say for example, for increment equals 0. So the I is equal to 0. Yeah. I is less than perfect. And so I++. And there we go. So now we need to open
Why am I getting errors here though?
Do we? Oh, because semicolons. Yes.
That's where I always go wrong. Okay.
Perfect. Curly brackets, and that's it. So now we have a nice looking for loop. So we need to create strands. So basically box geometries that are elongated.
Okay.
So now you know how to do that, right?
So I'm going to say this dot, no, I'm going to say const strand equals new 3 dot square.
Almost. So as you said, out of the, you did a pun. Yeah.
I'm working in 2D here. Box geometry.
Yeah.
And then like we want like one of that, like when 10-1 again.
Let's say that.
Okay.
And actually we can already implement a bit of generative design into it. So why not use a random function into that? So just to organize our code a bit better, above our strand, let's create, let's say, another const, maybe called, I don't know, L for length, maybe, I don't know. And pass in a bit of random. Yeah, you already know that.
Math.random, and then we're going to say math.random times 10.
Exactly. Yeah.
So this is just going to, math.random will give us a random number between 0 and 1, and then we multiply it by 10 so that we get a random number between 0 and 10.
You already are a generative artist at this point. So yeah, perfect.
So now I'm guessing that what I'm going to do next, I'm going to go out on a limb here and say this.strandGroup.add strand.
So almost.
Okay.
But this is the right idea. As I told you, you have a scene. In this scene, you have objects. What are objects composed of in Three.js? The geometry and the
mesh. The
material. And this is a mesh. Yeah.
Okay.
So now we have our geometry. We need two other things. Create our material and put those together in a mesh.
Okay.
Yeah. So let's create a material first. So what can we create actually? So the custom shader that I did is actually a recreation of a material already implemented in Three.js called a mesh normal material. So we will just instance that.
Okay.
So let's create a const material, let's say. And this is equal to a new 3 dots. So mesh normal material. Perfect. And now we need to create a mesh to put all those together.
Okay. So what am I going to do?
So next line, you can create, well, yeah, let's do that this way. So you can create another const called a mesh. And this is equal to a new 3.mesh. And in those, you can pass your geometry and your material. So your strand and your material.
Okay. This is making some sense.
And now you got the right idea before.
So then I say this.strandGroup.add mesh.
Perfect. What do we need also? So now you have your strands in your group, but your group needs to,
How far off am I?
You don't need me anymore, actually. you just forgot the this.
Okay, thanks so much. You can leave. I will finish the tutorial.
You just forgot the this, but
This dot strand group.
Yeah.
I'm really, I have to confess at this point, and if in case you can't tell, I'm really bad at object-oriented programming.
but yeah, and now if you go back to our screen and reload the page,
Whoa. But so are we adding all of these objects to the exact same place?
Exactly.
Okay.
exactly. Oh, and also when you reload the page once again, we have a little problem is that our camera is a bit too near the object. So
Yes.
we just need to put it a bit further on the Z axis to have something that works just right away. So if you go up a little bit, you can see, yeah, we have this camera and its position is set.
Okay.
So it is at 5 on the Y axis. If we put 10, for example, yeah, you already got the idea, man. Just
Maybe 15.
yeah,
Okay.
nice.
Cool. And so this is like secretly, this is like 20 objects all in the exact same place.
Exactly.
Okay.
Actually, we created an L variables, but we never used it. Oh,
This one here?
I thought it was a 1. My bad. Yeah. So now we need to place them so that it creates a ball.
Right. So, because this is just showing us the longest one.
Yeah, exactly. So now we just need to rotate them
Okay.
randomly.
Okay.
And this is fairly easy. So we only need 2 axes. So this will be the x-axis. So this will be moving like this. So yeah, we'll need to rotate on the x-axis and maybe on the z-axis to have something that moves like that. Yeah. So we will need 2 other math dot random things
Okay.
to
So
work.
can I say like const x rotate?
Yeah, absolutely.
Math.random times what?
So we work. We don't work in degrees. We work in radians.
Oh,
So this
man.
is
You're taking me back to grade
trigonometry.
11 math.
Yeah. So how much does it take to do a 360 with
In a
radians?
radian? Like
Yeah.
pi?
So pi is half.
Okay,
So?
2 pi. So
we go.
okay. Come back to me in 5 minutes after I've wrapped my mind around radians. Times math dot pi. Is pi a constant
There
or
we go. Yeah, it is times 2,
times 2?
and that's it.
Okay.
So now we need to do exactly the same thing for, let's say, the z-axis.
Okay. So
Exactly. And so now we need to set the rotation of our mesh to those 2 things.
Okay.
So for that, it is going to be pretty hard. Obviously, it's not. We are in Three.js. We don't have to do any matrices, transform or stuff like that. So pretty easy. Mesh dot rotation dot set. And now, yeah, 3 arguments, the x, the y,
X, Y, Z.
and the z. So now I think you get the idea.
X rotate null or 0?
Yeah, maybe 0. Yeah.
0 z rotate. Okay. That's
And now,
done.
maybe
We'll see.
if we...
Oh my god.
There we go. So yeah, this is a nice crystal. Maybe. Let's add 50 or 100. Let's go crazy, actually.
That's it. This is mind blowing.
This really isn't the most optimized way of doing it. Actually, in Three.js, you have like instances and clones and stuff like that. So I do it this way so that it is easier to understand. But a better way of doing it is actually create one single strand just above our for loop, and then clone this strand to then play with it, so that your computer doesn't have to rework everything and instance every single one of those. But we can leave it like this for an instance. This will not be on a multi-million-dollar company. So yeah, we have our beautiful strands, and now you can see sky is the limit. So we can play with this axis on the scale, but let's play with others. Maybe,
Okay.
to play with the thinness.
It's
not a word.
The width, I guess.
Well, the thickness.
The thickness, yes.
Yeah. So we can once again create a new random variable.
Okay. So const thickness
Yeah.
equals math.random times.
So if we want something that is this or thinner, so this is 1 by 1. So
Yeah.
Man, there we go. What can I say? Like,
but which variable am I doing here? One or one?
That's a good question.
Or both?
So, as you saw with the camera, we did camera.position.set to reset the position of the camera.
Mhm.
To rotate, we just did the mesh.rotation.set.
Okay.
What are we going to do with the scale?
Mesh.scale.set. And then, so we're literally scaling it.
Yeah, we're rescaling it. So right now, everything is 1 by 1 by 1 by default.
Mm-hmm.
So you need 3 axes to rescale the thing.
Okay.
And so our strand, without doing the rotation, it is scaled on the y-axis by 10, like that. So we need to rescale the x and z axis.
So the scale is relative? So like if I say thickness,
exactly.
The
scale is relative, yeah. Another way of doing it is actually create a box geometry that is 1 by 1 by 1, and then put the L at the scale set function.
Or what if I just put the thickness here?
This could also work, but with doing this, we will have, let's say, if we want to animate it afterwards, we will have less options with it. I like to work this way, but what you said really, really works for what we want to do right now.
So is it okay if I look at what I've just done?
No. Of course it is. Yeah.
Okay, so this is getting freakier.
Yeah.
This kind of looks like my hair. Not right now. My wife just cut it for me, but normally.
You look pretty different from your Gmail pic, actually.
Yeah, that was back before COVID when I got haircuts.
Okay.
I mean, my wife does a great job, but I don't go to the barber anymore.
Well, there we go. So now, what can we do with it? Maybe make a move. That would be an idea.
Yeah.
Actually. So, actually, as I said, we redraw this scene every time on the update loop. So a thing that we could do is actually play with some of our variables in the update loop.
Okay.
So what do we need to do? We need to do a bit of algorithms. We have our group, and we want to access every child of this group. So just a simple loop to access those. Pretty easy. So we can use a for loop, but someone at the Make Meeples studio where I worked before told me that it was better to use a while loop in the update loop because it is much more optimized for the web.
Oh, okay.
Yeah. I think it is on lower levels that it is explained, but it should be better.
While loops can be dangerous, though. You need to be watch. You need to watch out.
This is the exact. You don't know how many browser I crashed with this particular method, but we can do something like. Let's go on an adventure, actually.
Let's crash this computer. This is company property, so let's drive it into a lake.
So let's try to do that first time.
Okay, so we're just going to say while true. No. What are we going to do?
So we need to create a variable that is going to be our increment thing. So why not a const here?
Because we cannot
because it is going to change it. Yeah. So let's just call it I for this instance, and equal to 0.
Okay.
And so we're going to increment this I for every single child that is in our strand group. So while I is less than
20?
3.
Oh, sorry.
You are absolutely right. We could do that, but since we want to do something that is dynamic, let's say that afterwards we want to play with the number of strands that are here, we can simply say, so this dot strand group.
This dot strand, that's it?
Yeah, strand group, dot children dot length.
Is length the property or?
Without, there we go.
Okay.
And then inside this function, we just need to do I++. And now we should have a stable while loop that isn't going to crash anything and not making your computer explode.
Except this happens 60 times a second, and then this while loop happens 100 times for every update. So we have a function here that's running 6,000 times a second.
Yes.
Okay.
And your computer can handle it, actually.
Okay.
Yeah.
But I'm not going to run a console.log here.
Exact. Oh yeah, this is a big one. Yeah.
Okay.
And now inside that, what do we want to animate actually? What would you like to do?
You mentioned we could rotate it.
Yeah.
That sounds cool.
Yeah. So actually, to rotate stuff in Three.js, like there is this thing with 3D stuff where you can play with the position, scale, and rotation.
Okay.
And in Three.js, those three things work approximately the same way when you want to modify them. We already saw the set function that allows us to modify every single three of those vectors. But you also have, for example, if we want to move everything to the right, we can simply do directly translate x, let's say. And this is going to move by the amount we put inside those things. So let's say that we want to rotate each and every one of those. So we have this while loop, and we have this I that takes the indexes of those childs. So now to access those childs is pretty simple. If you go in the strand group, so if you do this.strand group, so you need to do that above the I, because if you don't do that, you are going to have...
We're going to be accessing the next one in the group. So strand group is an array?
Yeah, so the children is an array.
So then I can say children I.
Exactly. So now you are accessing one mesh of the actual thing. So now we can play with it like we played with the mesh a bit above. So now let's say if you do rotate, and on the x-axis, big X, and now in parentheses, you pass in an argument. So the argument that you will pass will be the amount it will rotate each and every frame.
Okay.
And since we are working with radians, if we put something like, let's say, 3, it is going to be way too quick.
Okay.
So let's say 0.01.
And so everything is going to rotate the same way when I do this?
At the same speed, yeah. But since we also move them on the z-axis, it will be on different directions.
Okay. So am I allowed to press play?
I think you are.
Okay. Oh, lordy. Oh, my God.
Yeah.
That is really wild.
So as you can see, they are all lining up at one time. This is pretty logical. So
it feels logical, but I still don't understand why it's happening.
So basically, like we did before, we can also do that with the z-axis, maybe.
So I'm going to say, and so because these are all placed differently, they will all rotate differently.
Normally, yeah.
Oh my, holy. I mean, this just looks so psychedelic, you know?
Yeah. This is my thing, actually.
Okay. Can we add Y? Would that do?
So since the strands are scaled on this axis, if you rotate on the y-axis, it's just going to move like this. Not anything major. We can do it, but it will not be anything too big.
Oh, now they're lining up again.
Yeah, because we have the same...
Because they're all rotating.
Yeah, exactly.
In sort of like a symmetry.
Yeah, an idea would be to create an array with different random speeds that we decide to increment them in the first for loop. This would be an idea, but let's just take the y out and play with the scale. Oh, this is an idea.
I don't know. I just thought, why not?
Why not?
Okay. So you mentioned an array.
Yeah.
So what are we going to do with the array?
So...
Am I going to put it here?
My array idea is to, right now, you know that they rotate all at the same speed, right? So a thing that we can do is make them rotate at different speeds to make something even more organic. So not in the update loop, but in the for loop of our initialization of our strand group. If you go a bit above.
Okay.
Yeah, and create above the for loop a new array that we need to access in the entire object. So this dot, let's say, speeds. Yeah, and this is a new array. Nice. And so you can leave it empty. And inside the for loop,
I can, sorry?
Oh, you just leave the speed.
Oh, leave it empty.
The speed
okay.
empty. Yeah, we will hydrate this array in the for loop. Not in this one, in the one in the initialization.
Okay.
Yeah. So in that at the top, just before our L variable.
Okay.
Yeah, we can do something like this speeds.push to add a new variable to it.
This.speeds.push.
Yeah, and in there, we can pass a random argument.
Math.rand. Just like that.
So this will be between 0 and 1, and 1 will be a bit too quick for us. So let's say 0.01 once again.
Okay.
Yeah, and now we have those speeds, and we have the same number of speeds that we have of strands.
So each speed in this array correlates to a strand in the children.
Yeah, not directly, but we are going to plug them in
Effectively.
the update loop. Yeah. So now, if we go in the update loop, we can simply change those values in our rotate thingies by the speed and passing the I as an index.
So this.speeds.
Yeah.
I.
And passing the I. Yeah.
And should I do it for both X and Y, or let's start with, X and Z?
I think this will not be a huge difference. We will have something pretty organic right away, but yeah, let's just see.
Okay, so now this looks, like you said, it's quite organic. Like this looks more natural.
Exactly. Yeah. This is one of the things that I like to do with code. Actually, is to create something that is not too geometric.
Mm-hmm.
Like we are on a computer where everything is square and it plays with pixels. So having something that looks, I don't know why this was or why it comes up when I'm describing those, but windy. You know, like
I love that.
Yeah, like flowy maybe.
Yeah.
Ooh, this is a nice word. Yeah.
So I added the speeds variable to the z-axis, and now we're seeing a lot more variation, I suppose, because it's exaggerated 10 times.
Exactly.
Okay. Very cool.
Perfect. So now one last thing that we can do. Now we have a pretty regular ball in terms of size, and it not always moves. To give it a bit more life, one thing that we can do is take each and every one of those strands and make them shift on the z axis.
Okay.
So we need to think mathematically here. What is a function that periodically moves from time to time, and just that looks like this on time?
So we're going back to high school math.
Yeah.
We're talking sine, cosine, and tan.
Man, you basically have everything. Yeah, when you know random things, a bit of noise, of Perlin noise, and a bit of sine functions, man, you have your thing.
So would it how far off base again am I if I say this dot strand group dot child? So far am I going the right direction?
Yeah, go ahead, man. Go ahead.
Dot I dot scale. Yeah.
Mm-hmm.
And then I want to scale the z-axis, so I'm going to say 1.
Oh, you want to scale the z-axis?
Do I?
So how did we scale the cube to make it look longer?
Oh, right, that was on the y-axis. Yeah. Okay, so I'm going to say 1 and then my variable, and then...
This is where we have the math.
Math dot sine?
Yeah.
And then... Okay, let me think. I don't know. I have no idea.
Okay. If we pass, let's say, only, for example, the index of our strands, we will simply quantify, like let's imagine the sine function. We will simply quantify a particular time on this sine function, but it's not going to move. You agree, right? So something that we can do is take a variable that increments every single frame. And for that, we can do two things. Either we create a variable that we simply increment on each update, or we can simply use a nice...
No?
No. But there is this variable in JavaScript that just take the time that is passed since 1970.
Unix time.
Yeah, date.now.
We're literally just going to use date.now.
Date.now, so this is a method. And so if we do that, this is going to be really too quick. So let's do time 0.001. Okay, so sine, how does it vary actually?
Oh, I don't, periodically, but I don't know.
So it goes from -1 to 1.
Okay.
So we will have a bit of a hard time if we keep it like this. So actually, instead of directly do our math in the scale loop, in the scale method, let's create a new variable just above that. So let's call it let's a y scale is equal to that. Yeah, and so that goes between -1 and 1. So if you go +1, so now we are between 0 and 2.
Mm-hmm.
So if you put a parenthesis around all of that, and do that times 0.5, so now it varies between 0 and 0.5, but we don't want them to go squish all the way down, right?
Okay.
So maybe plus 0.2. Right at the end of that.
Okay.
Okay. So now, if we see what is happening on our screen, how did we move the position of our camera? That position.
.set.
Yeah.
So do I want to say scale.set?
Yeah. And now?
Whoa.
Nice. But the thing is, they are all moving at the same time.
Mm-hmm.
Something that we don't want. So we want to put. So we would like to put an offset on those.
Mm-hmm.
How can we do that? Do we have a variable that is incrementing in this loop? Yes, we do. The index. So if you just do +i in this sign function, somewhere.
So date.now times 0.01
+i.
plus I. Just like that?
Yeah.
Should work?
Yeah.
Ooh.
There we go.
Wow. And you're actually watching this on the screencast, so you're seeing kind of janky version. Yeah. But what we've got here is really, really beautiful.
It's pretty nice. Yeah.
That is...
So there we go. Create an NFT and become a millionaire. And that's it.
So the starting bid for this NFT is going to be 5 million euro. And no, that is so cool. So I'm still trying to kind of wrap my head around the fact that in the last 20 minutes, I just created a generative 3D art.
And as you can see, pretty easy.
And we started with your starter, which is very unopinionated. When I looked at it, I thought like, oh wow, this is like a heavy duty starter. But like actually, it's really, really just like the basics, like just starting a 3D canvas.
Yeah, exactly. There is not that much to it. There are some debug tools and things to resize the canvas and stuff. It's just to have it ready for production. But really, the work here is done by Three.js.
Yeah, and just like, I mean, you said Three.js did all the work, but like we wrote. How many? That's 8 lines of code there, and then 10 lines of code there. So is that correct? We wrote like 20?
Yeah.
20 lines of code?
The thing is not this much, as you can see, where you can have fun right away. And the thing that just amazes me is that this is done on top-of-the-line cutting-edge websites, and anybody can do it. This is the thing that is really, really interesting. Anybody can do astonishing things on a computer with, as you said, 10 lines of code.
So cool.
Yeah.
Wow. Well, thank you so much. We had a blast today. Thank you for everything, for talking to us about your past experiences and for joining us here. And I can't wait to see what else you work on in the future.
Thanks, man. Thanks for having me.